Good morning. This experiment built by a student, Jason Roderick, a few years ago, does a study on a pump. We're able to generate pump curves for the pump, acting with a throttling valve, and then we're also able to generate pump curves using a variable frequency drive. The data that we can collect includes volume flow rate, the pressure differential from the pump, and the power that's used. First thing to do is to measure the specific gravity of the fluid. To do that, we use a hydrometer. I may have misspelled that on my handout. Looks sort of like a thermometer. If we can get close enough and read a scale, maybe we can't with this camera. The scale is going to give us specific gravity, and it starts out with, you can zoom in on it. Is that readable? Barely. That first number is 1, this number down here is 1.1, then 1.2, 1.3, like that. There's marks in between. All we need to do is get it floating in the fluid and just let it bob around like that. It's quite difficult to see it bobbing in there, but the students can get close enough and spin it a little bit, they can read the scale. It'll come out to be a specific gravity of about 1.05, something like that. Too much glare in here. Be sure this thing comes out before the pump turns on, or it'll get sucked down the drain. The rest of what's here, there's a power meter hooked up. This will give us the power that the system's using in watts. There's a LabVIEW program over here that's coupled with a flow sensor and pressure transducer, and this will give us the volume flow rate, liters per minute, and the pressure differential, pounds per square inch. What a bummer, inconsistent units. This is the volume sensor up here. It's a paddle wheel type sensor, and then this is the pressure differential sensor. It's an electric device, uses what's called a Wheatstone bridge. The calibration on this is all built into the LabVIEW program. Well, to get this going, then, the first thing to do is to plug the pump in, and with this white cord that needs to be plugged into the gray socket from the power meter so that the power runs through the power meter. Let's see here, need 2 hands, but I can, there we go. When we run the program in LabVIEW, then we'll start the program and let it run for a half a minute or so. And what it's doing, I hit start is up here, and Mike knows where that is. We'll let it run to get the zero pressure difference voltage reading from the pressure sensor. We'll use that to correct the pressure readings after this. So we hit this stop right here. So there's no fluid moving. Everything's sitting still and been still over there. We click on stop one time, and now over here on the right we get the corrected average pressure, and there's a little bit of drift in here, up 100th, 200th, 300ths of a psi. We'll also be able to get the volume flow rate right here, and this is in liters per minute. To turn it on, then there's a switch off to the side. You zoom back. Switch is over here on the side. We'll turn that on. That starts things moving. You really can't tell much of anything's moving now. Just hearing the pump is all we can do. If we look over at the screen on the computer, we can see that we're getting a pressure differential down here on the lower right, and there's also a volume flow rate. The students should note what the maximum flow rate is, about 38 liters per minute. Record this. Once it's stable, record the volume flow rate, record the pressure differential, and also record what the power meter says over here. This is in watts. So we've got 340 watts for that flow rate and pressure difference. Next thing then is to find 4 more flow rates by using this throttling valve. And I'll just turn the valve to slow the pump down, and we'll look over on the screen, and I was at about 40, so I want to get it down to say 30. I'll slow it down. It doesn't need to be right on, but about 30 liters per minute. Then I'm going to let it sit for about a minute. It lets the instrumentation stabilize, and also the system. The fluid system has some inertia, so it's going to take a while to stabilize. Once we think it's stable, we'll record the volume flow rate, the pressure differential, and then the power that's used up here in watts. And then repeat this, and we'll bring it down to roughly 20 liters per minute. Record the data down to 10 liters per minute. Record the data, and then turn this valve all the way closed, so we have 0 for the flow rate over here, and then we still have a pressure differential. This time 8.72, 8.73 psi is what I'm getting tonight. We're also using power, and this is the power in watts that the system is using. Well, that's the first phase of the experiment. We've used the throttling valve here to control the flow. One of the things that's we will notice is this is not a very efficient way of doing things, because we're putting a restriction on the system that's going to make it work harder, but it's actually putting less energy into the fluid. The next step then is to run off the variable frequency drive. That's this purple device over here. I'll turn the power off to the pump, and then I'm going to run the power through the variable frequency drive. So here's the two connections here for the variable frequency drive. This gets plugged in. We plug the pump into this. Now the power is going to go through the variable frequency drive. So the yellow cord gets plugged into the power meter cord, and then we plug the pump into the cord that comes out of the variable frequency drive right here. And two hands, or put the camera in my mouth might be better, I don't know. I'm going to put it under my chin. I don't want to stop the recording. There we go. So that's ready to go. We'll turn everything back on now over here. And then to turn on the variable frequency drive, it'll start out in the off position like this, but we turn it to on with this lock right here, and then we're going to turn it to forward, and we'll hear the pump start running. We want to be sure to open this valve up all the way, by the way, but forgot that. So the throttling valve is open. Now we're running through the variable frequency drive. It sounds about the same. We're going to do something different though. We're going to find that we can control the speed by controlling the frequency. And if we look close, we see we've got 60 Hertz showing. I can adjust this knob. I can bring this down to slower and slower frequencies. It changes to 60 Hertz from the outlet into right now about 49 Hertz, and I can keep slowing it down. You might be able to hear the pump slow down in the background. What we want to do is essentially repeat the last test. So we'll start out with running at 60 Hertz. This valve is wide open, and we will leave it open. And we'll go over here, we'll get the volume flow rate and the pressure differential at this setting, and we'll get the power reading. How many watts are being used right now. Then we want to slow the pump down. We'll slow the frequency down. We're going to look for about 30 liters per minute over here. Probably can't see that, but slow it down until we see about 30 liters per minute. About like what we did with the first set of data. And just let it sit there for a while until it stabilizes. It takes a while to stabilize because the fluid is surging. We can't see it very well. Once we think it's stabilized, then we will read the flow rate, the pressure differential, and the power that's used. And then we'll slow it down some more to the next setting. So maybe we'll try to get it down to 20 liters per minute if we can. And you can hear this motor when it slows down. It starts to make some goofy noises. But we'll get it down to 20 liters per minute. Record the pressure difference, record the power. We also want to note the frequency that we're running at. Then we'll try to bring it down to 10. and it's doesn't sound so good, but it's going to make it, I think. Get it down to 10 liters per minute, read everything, and then finally we'll stop it completely. So we set this at 0. Actually it goes down only to 10 hertz. That's as slow as it's going to go. But we'll see we get no flow, and record the pressure difference, which is 0, record the power that's used, which is very low. So this will all get written up, and what's going to happen is we're going to find the efficiency of the system. So we'll go back to some one of the earlier chapters where we figure the power that goes into a fluid from a pump, and we'll look at the power that goes into the system, the watts, and we'll be able to determine the efficiency of our system and maybe understand some of the benefits of a variable frequency drive then. So hopefully this makes some sense, and Mike can help with the lab view.